Hey everybody, got a real weird one. Not a repair, actually a technical debunking video. This is fine. So I'm sure some of you have seen this product on the internet. It allegedly is a flavor enhancing spoon. Enhances flavors. Sweet, salty, sour, savory, bitter. Heightens taste, improves aftertaste, all this stuff. Built-in advanced electronics to excite and stimulate the taste buds. Works great with yogurt and blah blah blah. Long story short, it doesn't do any of that, at least as far as I'm concerned. I've seen enough review videos on this to know that it's a bunch of nonsense. The packaging is kind of funny. Just look at the back. This always cracks me up. Make sure food completely covers the emitter as you eat. The LED light will light up to indicate the technology is activated. So the technology is activated. There's an electrode under the back of the spoon. There's an electrode in the front. They call that the emitter. And then there's an LED. The crazy part is this thing's disposable. You're supposed to throw it out once it's used up. See if we got anything under the Banggood sticker or whatever. There we are. Hand wash only. Do not put in the dishwasher. Do not microwave. Yeah, batteries tend to be upset when you microwave them. Now, I'll put a couple links in to Sorted and a few other folks who have tried this out. Thunderfoot did a really cool video on the theory behind how this should work, even though it doesn't. The one thing I haven't seen though, and I didn't look super hard, but I looked well enough, I think. I didn't see any teardown videos. I didn't see anybody looking to see what technology is activated. So I'm not gonna sit here and eat stuff in front of you. I am going to instead, we're gonna tear this thing down and see what the technology really is, and we'll go from there. Now personally, zoom you guys out a little, I think it's a fancy flashlight with a fancy switch. I think it detects an electrical connection between your hand and the emitter when you put this in your mouth, that the LED comes on. So I'm actually going to grab a piece of wire, and we're going to hold the piece of wire here, and I'll touch it to there, and let's see if the light comes on. Pseudoscience is strong here, I think, because the company that sells these also had some kind of like neural thing, like a headband kind of thing with batteries in it that would allegedly stimulate your brain like coffee. You know, pseudoscience. So let's see, we're going to touch it. Yay, look at that. So if I hold that here and then touch that, the technology is activated. Technology, no technology. Technology, no technology. So you can see that's just a piece of wire. I didn't do anything special. I'll do it again so that you guys can see there's nothing funny going on here. Wait a minute. Make sure you guys can see everything. I'll hold that. And then technology. Let's throw a meter on it and see what we measure between those points. Alright, so I have it on DC volts. Let's pull that cover off and get a little bit better connection. Holy crap, 12 volts? So this is negative and the bottom is positive. That actually kind of makes sense. They call it the emitter. So I guess this is a PNP spoon. Alright. So 12.6 volts. That's surprising to me, actually. There's 12 volts across here. I wonder what we're going to find battery-wise. I'm going to go with maybe a 4 stacked watch batteries, you know, little cells. That's my guess. We're going to find them here, maybe. And then an op amp. that senses the connection, because obviously, actually, let me see something. I was going to say, obviously you're not feeling 12 volts between your mouth and your finger, so let's see what kind of current is going through there actually too. That would be good to know. So I'm on the milliamp scale, and we're just going to do a dead short the thing out and see what kind of current's going through there. So that looks like we have 120 milliamps at 12 volts. 150, so 0.15, 0.15 milliamps. We're on the milliamp scale. So that's very low. That's not even 1 milliamp. That's what, 0.15, so that's low. Very low power. So this thing's a milliwatt worth of power through it. But 12 volts, that's honestly very surprising. So let's open it up. Enough doing the electrical specs and whatnot. Let's just open her up and see what's going on. Alright, so I have some implements of deconstruction. Let's get the spudger first. Let's see if we can get in between the foam. Oh, we can. Just trying to break the foam loose, or the rubber loose, the silicone. It's a soft silicone rubber. There we go. I see an alkaline battery looking back at me. I only see one battery. So they must be using a boost converter. So we'll probably see a boost converter circuit, I'm assuming. Because unless that's a 12 volt battery. It doesn't say. Can't really read it either. Now let's keep digging this stuff out. Actually, this stuff might be overmolded. They probably put that thing in there and then drop it in a machine that does that silicone overmolding. First I thought maybe it was glued in, but I can see actually, yeah, there's a mold release mark, that little circle there. So the silicone is definitely, well, I believe it is overmolded. I hope I can return this. What do you think? Think I'll be able to return this? Oh, I should clarify. This was $30, by the way. This was 30 bucks. 30 bucks that once you use up the battery, you can't replace it. It's useless. So keep in mind, if you buy one of these, you're buying a $30 disposable spoon. So if you say that to yourself out loud, it really sounds silly. I bought this to show you guys. I saw Thunderfoot's video, thought it was great. I loved how he tested with the power supply and all that. But I was kind of hoping he would have opened it up, and he didn't. So I will take the $30 hit. Maybe I'll see if Amazon will take it back after I tell them it doesn't work. My yogurt doesn't taste any different, but the insides all fell out. What do I do? Let's see. Come on. A little more. Get that crap out. There's the emitter. You can see the back of the emitter. And it's got a wire. Make sure I don't get underneath that wire and accidentally tear it out. Okay. Now can we get that internal battery assembly out? Work my my way down around the sides. They stick it together maybe? I see another seam. Well, let's just see if I can get it to pry out. Like that. Beautiful. Hope I don't break the circuit board. I'd like to get the whole thing out. Well, that probably wasn't good. Whatever that, well, definitely, that definitely wasn't good. I'll just rip the battery out. Well, let's look at the battery. Let's see what kind of battery this is. A120, not A123, crud, what are they called? 23A, there it is. 23A, that's a 12 volt battery. You see those in remotes sometimes, car remotes. So that's how they're getting power, getting that 12 volts at 0.15 milliamps. And that was with the LED on that 0.15 milliamps, so it's very low current. I have a hard time believing 0.15 milliamps at 12 volts could affect anything. Let's see, can I get this? Just trying to get that, get all that glue loose. See if I can push the emitter out like that. Alright, so it looks like the electronics are all in here. I'm just trying to get it loose. Silicone schmutz. Here we go. So we have some screws. Two very little screws. Yeah, we'll get the micro screwdriver. So we got a screw here. All right, 1 and 2. Oops. It's not a very good spoon anymore. There's the LED on the board. Little guy. Let's see, we get underneath. Yeah. Here it is. And I knock the LED off. Here's the LED. Oh, so the LED is part of the circuit board here. Oh wait, I have it upside down. It goes here. So here's the circuit board. So we have to find the technology. The technology is under this gross potting compound. Which I might have to do this. I might have to depot this off camera. This is going to take a little while. We want to get to that circuit board. Let's see, can I... Let's see, can we go down here? I really want to see what the mechanism is. I suspect, like I said, it's probably an op amp or maybe one of those touch sensor chips, because you can have them latch or toggle, and they're a SOT23 package, so they're really small. They would fit in here. Wouldn't surprise me if that's what we end up finding. Alright, I'm going to do this off camera. Okay, I decided to start the camera back up because I'm finding that if I slide this flathead under here, the material's starting to give way. If we can get the finger thingy off, maybe we'll see some electronics. Not yet. Oh, we have a model number though. Model E8025. So this board actually has a model number. We'll take that thing off. That's just a contact. Keep all the bits together. See, I think the stuff we want to see is under here. That's going to be tough. Let's see if I can... Oh, it will crack off. That's good. Alright, so that's a trace to the LED. Okay. We'll just keep going down and trying to break that stuff off. It's hard. They're trying to hide this super secret amazing technology from us. Hopefully if I get this trimmed off well enough, we can split it and the bottom will come off and the top will come off and we'll be able to see everything. Solder point for the negative. Solder point for positive. And then end of the board? Yeah, end of the board back here. Alright, so we got to clean the top off now. So let's see, can I get that to pop loose? No. Okay, I see a resistor starting to show its face. Let's see if I can... I was hoping that would just flake off. If you get this stuff at the right angle, it just pops off. Alright, I'm seeing a chip. Transistor maybe. Maybe they have just a simple transistor sense circuit. Yeah, there's the transistor that came up. Or MOSFET technically, where if you touch the gate, it'll turn on the, it's enough to turn on the source to drain connection. And we got another resistor starting to show up. Come on. So I was expecting one of those touch sensing ICs, set up for toggle, but it seems like they're just using a MOSFET with wire hooked up to the gate. There we go. There we go, nice. I like that. So transistor went here. We have a pair of resistors. So let's see what we got on here. What is the resistor to the LED? 6.8K. And then 91K. Alright, so collector goes to the resistor, which probably... Is that gonna... It's probably not gonna make it to the LED right now because I messed the board up. But let's see if that's what this goes to. This trace that's hanging off on the bottom here. This might go to negative actually. Not going to anything. Although I may have really torn it up. Where does that go? Yeah, I accidentally tore that up back here. Dang, that's a shame. But I'm pretty sure this is how the circuit works. So let's see, from negative, where does negative go? Let's see, negative goes to there. Alright, positive goes to there. Okay, so positive goes to the base, and then the collector looks like it's going out to the LED, and then the button would also go there. I'm going to have to see if I can reverse engineer this. I'm going to try and reverse engineer this circuit for you guys, even though I chewed it up pretty good. To see if how bad that's actually pretty shredded. I don't know if I'm going to be able to get any readings off that transistor. Let's see, we'll go to diode check. Let me flip it so I can get to the, let's see, there, and anything? No. I have a feeling I ripped this thing to shreds. Yeah, it's pretty bad. But it's simple. So, I'm going to put a diagram up of the circuit. So basically what happens is you're completing the circuit and turning the LED on. There's a 6.8K and a 91K resistor, a transistor, an LED, and a 12 volt power supply. See, 6.8K. Come on. 91K, and that's it. And then the transistor that got ripped off the board. So between that, this, the quote-unquote emitter. Oh, here's the emitter. We didn't really look at that. It's literally just a chunk of metal with a wire soldered to it. It's nothing in particular. So it's basically like a touch sensing light when you're completing the path between there and between these two pieces with your mouth and your finger. Wait a minute, I grabbed the wrong, here it is. Between these two pieces, sorry. So there's our circuit, that's our switch. When it senses the resistance connection between here, LED comes on. So there's literally no technology in this thing. It's a straight up piece of junk, scam, whatever you want to call it. Doesn't work. Isn't worth wasting any money on unless you wanted to do a YouTube teardown video that debunks junk science, fake science. That's all it's good for. So save your money, save your time, save your hassle, save your sanity. And if you want food to taste differently or taste better, go watch a cooking channel and learn how to use spices, or put extra butter on it. That seems to always work. And there you have it. That is what the inside of a SP00NTEK, it's genius, no it's not, spoon flashlight. That's literally all it is. So check the description if you want to see the reverse engineered circuit diagram, in case you want to build your own pretend flavor enhancing spoon flashlight. You might be able to build it a lot cheaper than the $30 I paid for this dumb thing. So anyway, if you don't subscribe to my channel, think about hitting that subscribe button. It would help me out and doesn't cost you anything. If you found the video remotely entertaining, do me a favor and hit that like button. It helps me out a bunch. And most importantly, as always, thank you for watching.